Hello everybody. In today's lesson we are going to learn about Boolean expressions. Now Boolean expressions can be written in two forms, either in the SOP form, which is also known as the sum of product, or the POS form, which is also known as the product of sums form. Now let us study one by one. Now sum of product, from the name itself you can understand this is an expression which is a expression formed by the sum of some product terms, and each of those product terms are min terms. Now what are min terms? A min term is a product term of n variables in which each variable appears once in true or in the complement form, that is either like a or a dashed or c or c dashed, but it is important that it appears only once. Now hence the expression formed by adding such terms is known as the min term expression. I have taken an example over here. It's given a b c dashed plus a dashed b dashed c plus a dashed b c. Now in this entire expression you can see it contains three terms, and each of those terms contains three variables a, b and c, and there is no other fourth variable anywhere appearing in the expression. So we assume that this expression is a three variable expression, or sometimes it is given in this way, that f is a function of a, b and c, and the expression is this. So this also helps as a guideline as to see whether all the variables are there in the expression or not. Now let us come to product of terms. Now in product of terms, again from the name itself, product of sums, it is an expression where you have multiplied or you have found the product of several terms which are sum of the variables. A sum term of n variables in which each variable appear once is called, in the true or complement form, is called the max term, and the max term expression is the POS expression. Now see, this is a POS expression. Again the same thing, in both the variables a maximum of three variations are there: a dashed bc, a b dashed c dashed. So here again you can be given that if f is a function of abc, whose expression is given in this way. Now in both the cases we observe that all n variables are there in the expression in each of the terms. It is very important. Such an expression is also known as a canonical form. We will do it in the next part of it. Now from here we can also get another form of expressing Boolean expressions, which is the cardinal expression. Now in cardinal form basically we give the numbers. Now you know that if there are n number of variables, then there are 2 to the power n possible combinations of a, b and c. So in this case you can understand if n is 3, because in both the cases only 3 variables are there, then obviously we will have 2 to the power 3, which is equals to 8 combinations numbering from 0 to 7. Now when we write SOP expressions, each of these terms are min terms, and they are written or denoted with a small m. Now from this expression, if we have to write the cardinal form, we have to see that which binary number are there representing. Like see in this one, a b c dashed is equivalent to 1 1 0, because in SOP we take the true form as 1 and the complement form as 0. So we can write a b c dash as 1 1 0. A dashed b dashed c is 0 0 1, and a dashed b c can be written as 0 1 1. Now if you find out the equivalent decimal numbers, what do you see? This is 6, 1, 2, 4. These are the place values. So this is 6, or this term is also written as M6 in this way. So we don't write this. Now this is 001 means this is decimal 1, so this is M1, and this is 011, that means 3, so this is M3. So this can be written as, so this expression can be written as either, usually we write it in the ascending order, M1 plus M3 plus M6, or we can also write as sigma of 1, 3 and 6. This is the cardinal form of this expression. Now if we move on to the POS form, if you want to write the cardinal form of this one, again we have to find out the decimal equivalent of these combinations. Let's start that. I'll just divide the page for convenience. First term is A dashed plus B plus C. Now in max terms, these are two max terms, it is denoted by a capital M. This is equivalent to 100. When we have come to POS, that is the product of sums, the complemented form is 1 and the true form is 0. So here A dashed will be 1 and B and C will be 0. So this is equals to 4. So this is M4, and the other term is A plus B dashed plus C dashed, which is equals to A is the true form, that means 0, 1, 1, which is equals to 3. So M3. So this function can be written as either M3 plus M4, or it can also be written as pi of 3, 4. This is the cardinal form of this expression. Now let us see how we obtain the sum of product and product of sum expressions for a particular function. Now you can see I have drawn a truth table. It's for a function of 3 variables a, b, c, and this x denotes the output. Let us consider it's a random word problem or random situation where it is 1 for these cases. I'm putting the ones randomly, okay? And the others are 0. Now in order to obtain the min terms for this function, you will have to write the expressions. You will take the terms for which the output is 1. So this is, now see, I have written this purposely so that it's easy for me to get the cardinal number. So this is M0. See, I have got a 1 in this row, that means this is row number 0. So M0, and this term is A dashed, B dashed, C dashed. Remember, min term means SOP, product terms, and max term is for POS. So again this is, see this again I have got a 1 in row number 2. So this is M of 2, and the term is 0 will be A dashed and B, C dashed. Again I've got a 1 here, so this is row number 3, so M3. So that is A, B, A dashed, B, C. I've got another 1 in M5, so that will be A, B dashed, C, and finally in M7, which is A, B, C. So this is how we find out the SOP function, sum of product expression for this function. Now if you need to find the POS expression for this function, then you will go for the zeros. Now in the same question, you will not be asked to find out both the min term and max term. You will be asked either of them, so you can stick to any one of them. Now for max terms, we have product of sum, so each term is a sum term. Now sum again, so we have here, we'll find the sum of these but in the opposite notation. It's capital M, row number 1. So, and the term is, what is the term? Remember, in max terms, 0 is the true form and 1 is the complement form. So you have A plus B plus C dashed. Again I have a 0 here. This is row number 4, so that is M4. So again A is 1, so this should be A dashed plus B plus C, and the last one is M of 6, and the term is A dashed plus B dashed plus C. Now you see, for the same function I have got all the main terms, I have got all the max terms. If we take this function as f ABC, then f of ABC can be expressed, if it is expressed in the SOP form, then it is equals to the sum of all the main terms. So that is sum of M0 plus M2 plus M3 plus M5 plus M7. We can also write this as A dashed B dashed C dashed plus A dashed B C dashed plus A dashed BC plus A B dashed C plus ABC, and this can be also written as sigma of 0, 2, 3, 5, 7, 0, 2, 3, 5, 7. And the same function when written in the product of sum way, you have to write it as M of 1 dot M of 4 dot M of 6, which is equals to A plus B plus C dashed dot A dashed plus B plus C dot A dashed plus B dashed plus C, which can be also written as pi of 1, 4, 6. So both these expressions are for the same function but in two different forms. Now you must notice here that in the cardinal form, if I am given this cardinal form and I have been asked to find out the POS of this expression, then simply you need to write the sigma will become pi and you will have to write the missing terms. See, you have 0, you don't have 1. So what all numbers are missing from here? See, 0, 1 is missing, 2, 3, 4 is missing, 5, 6 is missing, and you have 7 here. See, the max term is also pi of 146. So basically, if either PO is given, then you can find the SOP and vice versa. We learn to convert a minimal expression into its canonical form. What is a minimal expression? A simplified expression is called the minimal. That means minimum number of terms. And canonical form is a form in which all the terms contains all the variables involved in the function. Now you can see here in this expression that this is in the minimal form. Why? Because it is given that f is a function of x, y and z. And see, the first term is only x, so y and z is not there in this term. In the second term, y and z is there but x is not there. So it is proving that this is a simplified form. Now I have to convert this to canonical form, that is I have to insert the missing variables in each one of the terms. So let us write down the question once. X plus yz. Now what we are going to use here is this expression, this law, that y plus y dashed is equals to 1. Now see, this is the SOP form, so it is sum of products. So each term is a product term. Now in order to keep this product term unchanged, it should be multiplied with 1. And here also the second product term, if multiplied by 1, then the expression is remaining unchanged. But in the first one, I will be putting 2 ones. Why? Because in the first term, 2 variables are missing and the second term only 1 variable. Now instead of these ones, I will put this form of the missing variables. So in the first term, I will write y plus y dash and z plus z dash. So this one has been replaced by this expression and this one has been replaced by this expression. So in the second one, yz, and this will be x plus x dashed. Now I'm going to use distribution law to expand the terms. So this is xyz plus xyz dash, that is this one being multiplied with these two. Again this xy dashed z plus xy dashed z dashed plus this is xyz plus x dashed yz. We try to maintain the order of the variables as given in the question. Now I'm going to look for some repeated terms, if any. Like see, this term and this term is the same, and we know that according to the idempotent law, a plus a is equals to a. So using this law over here, I will write xy only once. This term is not repeated anywhere, so I have to write these terms. Nothing else is repeated, so this will come as it is. And this is the answer, that is your required canonical form. So you can see that the minimal form had only two terms and the canonical form is having 1, 2, 3, 4, 5 terms, and each term has all the three variables once, and it is either in the true form or its complement form. Let us do another example. I've taken over here AB plus AC dashed plus BC. So again here C is missing, so I will put 1. Here B is missing, so I will put a 1. Here A is missing, so again I will put a 1. So this one will be in terms of the missing variable. So here C is missing, so it will be written as C plus C dashed. Here B is missing, so this one will be written as B plus B dashed. And here A is missing, so this will be written in terms of A, so A plus A dashed. Now simply I am going to use the distribution law to expand the terms. So again I have one term which is occurring twice, and I will write that once using idempotent law. ABC dashed is also twice, so I will write once, then AB dashed C dashed plus A dashed BC. So this is your answer. So this is basically just the opposite of what we have done in the previous lesson. This expanded form was given and you had to find the minimal form. Now we will do the same for product of sums. So here the function is f is of x, y and z, and you have these two terms. You have to convert this to canonical POS. So let's copy the question first. Now see, in the first term you have x and y, you don't have z. So in the first term z is missing, and in the second term you have y and z, x is missing. Now here, in order to keep the expression unchanged, since this is a sum term, you have to add something that keeps the expression or term unchanged. So that is 0. So here also I will do the same thing. How many terms missing? One term. So I will add 0 also once. Now we know that x dot z dashed is 0 and x dot, so that is the product of any variable in the true and complement form is 0. That is the complement form, complement law, so we are utilizing here. So now these zeros will be replaced by the product of the missing terms, z dot z dashed, this is y dashed plus z plus x dot x dashed. Now I will just rewrite this in some other form. This first expression need not be rewritten. This one I will write. So I'm keeping the x in order just to maintain the convention. Now, using distribution law, what we can write is this term is x plus y dashed plus z, x plus y dashed plus z dashed. So this one, and this is, we're using the distribution law that a plus b into c, this is, I'm taking this as one term. We know that a plus bc can be written as a plus b, a plus c. So here a is x plus y dashed, and this one is z, and this is z dashed. So that is x plus y dashed plus z, x plus y dashed plus z dashed. Again, this term can be written as x plus y dashed plus z into x dashed plus y dashed plus z. Now let us see if we have any terms repeated. See, the first term is repeated, so I will write only once, x plus y dashed plus z, x plus y dashed plus z dashed, x plus y dashed plus z. So this is my answer. This was the minimal form with 2 terms, and see, the canonical form has 3 terms, and each term contains all the 3 variables involved in the function. Let us do the second one. You can see this, it is a function of 3 variables ABC, and the minimal form that has been given to us is in this way. Now in this term, C is missing, so I'll put 1 0. If 2 terms are missing, then we will write 2 zeros. Here A is missing, so I will write 1 0, and here nothing is missing, so I will not add any 0 over here. So this 0 will be replaced by C dashed. This one will be replaced by A dashed, because A is missing in this term. Now again, using this law, this is, you can write this as A and this is BC. So you have A dashed plus B dashed plus C into A dashed plus B dashed plus C dashed. Similarly, over here you can write B dash plus C dash plus A, so which I will write as A plus B dashed plus C dashed. Again, A dashed plus B dashed plus C dashed. This term will be, this will come as it is. Now let us see if any term is repeated. A dashed B dashed C. No, we don't have, so we will keep it as it is. A dashed B dashed C dashed. See, this term is repeated, so A dashed plus B dashed plus C dashed. I'll write only once. A B dashed C dashed is not there anywhere else, so this will also be considered, and this term was already there. So there were 3 terms in the minimal form or the simplified form, and here it is the 4 terms, and each term is a max term. This is the answer.